Welcome back to the functions unit. Today we're going to be talking about four representations of functions. So we're going to take one linear equation or one function and we're going to represent it four different ways. So let's go ahead and take a look at how we're going to do that in example A. So here we are at example A, and they've given us a word sentence about Allison. They want us to find the equation and the table and the graph. So we're going to have to use the word sentence that we have available to us to fill in the rest of our information. Now we have a couple of things down there at the bottom that will help us do this. If we can figure out our starting point and our rate of change, we can use those in both the table and a graph and an equation. So let's take a look. Allison has $50 in her bank account. That's going to be important information. Each week, she deposits $10. Again, depositing 10 every week, important information. Then they let us know that W is going to equal the weeks that have passed, and T is the total amount in the bank account. So those are variables that we're going to be using when we write our equation. So now that we've looked at our important part of our problem, let's figure out what the starting point is going to be. So it says that Allison has $50. So she's going to be starting with $50. So that's going to be our starting point. So our starting point is the 50 because that's where she has $50. That's our starting point. Then we need to talk about the rate of change. So the rate of change is going to be how much something is changing over how much time. So in this case, each week, she's going to be depositing $10. And we know deposit means to add. So every week, she's going to be getting $10. So we're going to write that as a fraction. So our rate of change is going to be $10 every week. So we've got $10 on the top over 1 week. That then simplifies to 10 over 1 or just equals 10. So our rate of change in this case is 10 over 1 or $10 every week, which then simplifies down to 10. Now that we have that information, let's use it to make something else. So let's use it to make our table. Now our table is labeled as X and Y. However, we were given the variables W and T. So we need to figure out which thing is the thing that's going to be changing by us and which thing is going to get changed because of that. And our two choices are weeks and total. So are the number of weeks going to be affected by the total, or is the total going to be affected by the number of weeks? And in this case, the total amount of money is going to be affected by the number of weeks that there are. So the number of weeks is going to be our X, and the total is going to be our Y. So now that we've got that, we got to go back to our starting point so we can start our table. And our starting point is 50. Now, is 50 the number of the weeks, or is it the total amount? And it's the total amount, so it's going to go in the total. How many weeks have passed? Well, no weeks have passed yet, so now that's going to be a 0. So knowing this, we can fill in some more information in our table because we're going to have 1 week pass, then 2 weeks are going to pass, then 3 weeks are going to pass, and 4 weeks are going to pass. And while that's happening, our rate of change is that we're going to add $10 every 1 week. So to the $50 after 1 week, we're going to add $10, and now we're going to have $60. The next week, we're going to add $10 again, and that's going to give us $70. The week after that, we're going to add $10, and that's going to give us $80. And that final week, we're going to add $10, and we're going to end up with $90. So now that we've got all of the information on our table, we can easily make our graph by, again, looking at our starting point, which in this case is 50. So we're going to put a point right at 50 since that's our starting point. And our rate of change is that it's going to go up $10 every week. And we can see that our graph is labeled number of weeks across the bottom and the amount of money across the side. So since we're going to go up $10, we're going to go up to the 60, and then it's going to go over 1 week. So there is our next point in our graph. Again, our rate of change is we're going to add $10 over 1 week. So there is the next point in our graph. Again, we're going to add $10, and then we're going to go over another week. And finally, we're going to add $10, and then we're going to go over another week. So you can see our rate of change helped make our graph because we knew it was going up $10 every week. Now the question is, do we draw a line to connect all of these points? And in this case, we're not going to, because Allison is not dropping off little bits of money throughout the week and then that ends up being $10 at the end. She's going to the bank and dropping $10 in her bank account at one time. So since the amount of money is not increasing slowly over that week, it's just getting increased once at the end, we're not going to draw a line. So now we need to make an equation. And we know whatever we do is going to be affecting the total. So we're going to start with an equation that's going to be equaling the total. Since whatever we do is going to affect that total. Again, we have to go down to our starting point to start. And our starting point is $50. So we know our equation, we're going to be starting with $50. So our total's going to be $50, and then we're going to be doing something. And in this case, our rate of change, we're going to be adding because we know we're going to be depositing money. So our rate of change is going to be the 10 over 1, which we can write as 10 over 1, and then times the number of weeks would be W. Now, that's one way we could write our equation. However, that's not really simplified because 10 over 1 is not a simplified fraction. So the equation we want to go for is the total is going to be $50 plus 10 over 1, which reduces to 10, times the number of weeks. And then no matter what number we plug into that equation will give us our total. So for example, if I were to take the 2 and plug that in, 10 times 2 is 20. 20 plus 50 is 70, and you notice that matches the 2 out of 70 on my table. So it works. That equation matches the word sentence, matches the graph, and matches the table. We've taken one form, the word sentence, and made all the others. Now let's do it with something else in example B. So here we are at example B, and this time they gave us the graph about snow at Mario's house, and they would like us to come up with a table, an equation, and a word sentence. So again, let's start looking at our starting point and our rate of change, because that information will be valuable in finding our table, finding our word sentence, and finding our equation. Is it possible to do these other things without finding the starting point and without finding the rate of change? Yes, it is, but it is a lot easier if you have that information. So taking a look at our graph, we can easily figure out where our starting point is by taking a look at where our graph starts. And our graph starts at 0 and 2. So our starting point is at 2 because that's the first point on our graph at 0. So our starting point is 2. Then we need to figure out what our rate of change is. So again, I'm going to be doing that counting that I did in the first example by going up and over. So it appears that it goes up about halfway to 3. So it goes up 1/2 for 0.5, and then it goes over 1. So every hour it appears to be going up 0.5. Let's check that with other points to make sure that's accurate. So again, it's going up 1/2 inch. So it went up from 2.5 to 3 over 1 hour. It went up another 1/2 inch over 1 hour. It went up another 1/2 inch over 1 hour. And I can say now that it appears that that is accurate. I don't need to do it for every point because I can tell that the rate of change appears to be that it's going to go up 1/2 inch over 1 hour, or 0.5 over 1, which reduces to 0.5. You can write that as 1/2. Either way is fine. I wrote it as a decimal. You can write it as a fraction, but it's going up 1/2 inch over 1 hour. So now that I have that information, let's put together our table. Because our table is going to be the next easiest thing to look at, because I need to come up with points. They already gave us points. They're the points on the graph. So let's use them. So looking at my graph, the two variables they gave me are T for time in hours and H for height in inches. So our height is starting at 2 inches. Perhaps it snowed the night before, perhaps it snowed like last week and it's still cold, so there's still snow on the ground. So we have 2 inches still at 0 hours. Then at 1 hour, we know that it's gone up 0.5, or we can even just look at that point on the graph and know that's going to be 2.5. At the next hour, again, it went up 1/2 inch. We can look at our graph and write the point down at 3.0 or 3. Either one is fine. At 3, we know it went up again 1/2 inch, so 3.5. And at 4, we know it went up another 1/2 inch to 4. So now I filled in both my graph and my table by knowing my rate of change and my starting point. Now again, using this information, I can go about making a word sentence because I know the situation that's happening at Mario's house with my rate of change and my starting point. So I can say that there are 2 inches of snow on the ground already. So Mario's house has 2 inches of snow on the ground. And I also know that it is snowing half an inch every hour. So I can just write that down. It doesn't have to be super fancy when you go to write these word sentences. They just have to make sense about the situation that's happening. So in this case, we know there's 2 inches on the ground because that's our starting point, and it snows half an inch every hour. So we're just stating what's happening. Now that we've done those 3, we need to put together an equation. They gave us the variables for the equation in t and h. So again, we have to figure out what our equation is going to be equaling. Is it going to be equaling the number of hours, or is it going to be equaling the inches of snow on the ground? And as time passes, the thing that's going to be affected is the amount of snow on the ground. So the height of the snow is going to be the thing that our equation is going to be equaling. So we're going to start with our starting point, which is 2. That's how many inches are already on the ground. And then we have to determine, are we adding to that? Are we subtracting to it? Since it's continuing to snow, we know that we're going to be adding inches. And in this case, we're adding half an inch, or 0.5. You can write either one every hour. So again, our hour in this case, we're going to be using t for time. So every hour, we're going to be starting with 2 inches and adding 0.5 times however many hours there's going to be. Now let's look at example C. So here in example C, they gave us the table, and we're going to need to fill in the graph, the equation, and the word sentence. So again, we're going to try and find our starting point and our rate of change. Now, without our graph, it might be more challenging to find a rate of change since we're just given a table. We're not really told what's going on in the situation, other than we know it's about Terrell's lunch account because that's the title of our graph. But we can figure out our starting point because our table starts at 0.20. So we know our starting point is going to be 20. We don't know what's happening, but we know that we're starting at 20. So let's start by plotting the points on our graph and see if then we can figure out what our rate of change is. So if we're starting at 0.20, I'm going to point a point at 0.20. 117 is the next point, and I don't have 17 on my graph, but I know that's going to be between 16 and 18, so I can put a point there. Then I've got 214, that one is on my graph. 311, again, that's going to be between the 10 and the 12. And then 48, that one is on my graph. So I can see now that it looks like my graph is going down. So whatever the situation is in my rate of change, it's going to be negative because whatever's happening is going down. So I know I'm going to have a negative rate of change. So when my graph is going down, I know my rate of change is also going to be down or going to be negative. So let's take a count now from one point to the next to see if we can figure out what our rate of change is going to be. So it's going to be going down, so I know that means negative, so we're going to be counting down. Looks like we're going down 3 and then over 1. We're going down 3 and then we're going over 1. We're going down 3 and then we're going over 1. So it looks like what's happening is we're going down $3 because it says the amount of lunch money on an account and number of days. So it looks like we're going down $3 every day. So since we're going to write that as a negative, we want to write that as negative $3 over 1 day. So our rate of change is negative $3 over 1 day, which is equal to negative 3 over 1, which simplifies to just negative 3. So now we've got both our table and our graph. We can very easily make our word sentence as we just talk about what's going on. And it looks like Terrell started with $20 in his lunch account, and he spends $3 every day. And that makes sense, because if you're going to have money in your lunch account, you're going to need to be spending it in order to get lunch. So our word sentence makes sense with our graph and makes sense with our table. So now we just need to put together an equation. So they gave us D and A as our variables, so we're going to be using those, and we need to figure out which is the thing that the equation is going to be equaling. Is it going to be equaling the number of days? Is it going to be equaling the amount of money in the account? And in this case, it's going to be equaling the amount of money in our account, so that's going to be A equals. Then we need to start with our starting point, and that's going to be 20. We know that from our graph being at 0, 20, and our table being at 0, 20. Then we need to figure out, is our line going up or down, or is our relationship going up or down? And in this case, it's going down, right? We're going down from 20 to 17 to 14 to 11 to 8. So we know we're going to be subtracting in this particular scenario. And we're going to be subtracting, as we can see, $3 every day. So 3 times D. And again, we can check to see if that works. If I have 4 days that have passed, 4 times 3 is going to be 12. 20 minus 12 is 8, and that is what I have in my graph, so I know my equation works. Now let's take a look at a scenario where it's just input and output. So here we are in a scenario where it's not talking about a real-life example. It's just giving us the output is 1 less than 2 times the input. And in order to do this, we need to know which thing is the output and which thing is the input. So whenever we're talking about functions and we're talking about the input, that is going to be our x. And anytime that we're talking about functions and we're talking about the output, that is going to be y. And that will always be the case. Whenever you're talking about input and output will be x and output will be y. This is important to know. You are going to use this for a very long time. Now that we've got our word sentence, let's see what else we can make. So it says the output is 1 less than 2 times the input. So taking that information, we need to see what else we can make. Now usually we would start at our starting point and our rate of change. And we can do that as well inside our word sentence here. So when it says the output is 1 less than 2 times the input, we can actually use that to make our equation first that will help us identify our starting point and rate of change. So since we're starting with the output, we know that all of our equations with y and x is always going to equal y first. Then, since I have 1 less than, I know that moves the -1 to the back, because less than means negative. 2 times the input. So then it's telling me that I'm going to take 2 times whatever the input is, and since I know the input is x, I'm going to have 2x. So as you can see, the output, which is y, is equal to 2 times the input minus 1. Now that I have my equation, I can identify my starting point and rate of change. Well, how can that be? We're not talking about a word problem situation. How am I going to know? Whenever we have an equation, we can easily identify the starting point as the number at the end of our equation, as long as it's equal to y, and our rate of change is always going to be whatever is multiplying the input, just like it was in our other problems. So our starting point in this particular case is going to be -1, and our rate of change is going to be 2 over 1, which simplifies to 2. So now that we know those two things, let's go ahead and make our table. And we can pick points so they didn't give us x or y, but our graph only goes up to 8 and -8. So we should make sure that we're going to pick points that aren't going to go above or below that, because they won't be on our graph. So I'm going to start with 0 in the middle because it's an easy number to work with. Then I'm going to go with -3, -2, +1, and 4. All of those numbers are below 8 or between 8 and -8, so they're probably going to end up on the graph. If not all of them end up on the graph, it's not the end of the world. We just won't be able to graph all of the points. So when we plug our -3 in, we're going to do it just like we've done before. We're going to take our y, we're going to take our 2, then plug in -3 and -1. 2 times -3 is going to give me -6, and -6 minus 1 is going to give me y equals -7. So my first one is -7. Now, I don't have to write it out every time. I could just multiply it by 2 and subtract 1. I don't have to write it out every single time that I see it. So -2 times 2 is -4. -4 minus 1 is -5. Now this works if you know your integer rules. If you don't know your integer rules, make sure that you plug them in. 0 times 2 is 0. 0 minus 1 is negative 1. 1 times 2 is 2. 2 minus 1 is 1. 4 times 2 is 8. 8 minus 1 is 7. So now that we have all of our points, we can plot those on our graph. So negative 3, 7, or negative 3, negative 7, excuse me, is going to be down here. Negative 2, negative 5 is going to be over here. 0, negative 1, 1, 1, and 4, 7. Now, are these the only points that are on the graph? No, there are lots of points that are on the graph that we didn't pick. So we're going to have to make sure in this particular situation that we have a line, because other points are on this graph, not just the ones that we have chosen. So let's go ahead and draw a line now that goes through all our points using a straight edge or a ruler. Now that I've got my line all the way through my points, I'm going to go ahead and make arrows. Now again, if your points don't fall on the line, that means you made a mistake. You either made your equation incorrect, or you plugged something in wrong, or you may have just graphed it wrong. All of those things are potential areas where you made mistakes, so you want to make sure that you check each thing first. Obviously, you want to check the thing that's the easiest to fix first, so make sure you graphed it correctly. Then make sure you plugged it in correctly, and then go all the way back to make sure your equation is correct. You don't want to do more steps than are necessary. Now let's move on to the next example. Here we are at example E, and this time they've given us the table, and we have to figure out the other parts. So looking at our table, one of the things that we can figure out right away is the starting point. Because we have the point 0, 4, we know that this graph is going to start at 0 and giving us the starting point of 4. So our starting point is plus 4, since it's 0, 4 on our table. Now we can figure out the rate of change from a table. We can figure out what's happening to the x to give us the y, but it's a little bit easier on our graph. So let's graph our points and then see if we can figure out what our rate of change is. So we're going to go over to negative 3, 1. So negative 3, positive 1. Then we're going to put 0, 4, over to 1, 5, 3, 7, and then 4, 8. So now that we have all our points on the graph, let's draw a line connecting them and put arrows on the end. So now that we've got a line on our graph, we've got 2 of the 4 representations done. Let's see if we can figure out our rate of change. It's a lot easier when we're using a graph because we can just count our ups and overs. So I'm going to be counting up from the 4, up 1, over 1, up 1, over 1, up 1, over 1. So our rate of change appears to be up 1 over 1, which reduces to just 1. So that's our rate of change, and we can use that information now that we have the starting point and the rate of change to give ourselves a word sentence. So we know that our graph starts at 4, and we know what's happening to the input is nothing. It's just being multiplied by 1. So our word sentence is the output is the input plus 4. Since we're not multiplying the input by anything, we're not going to write the output is the input multiplied by 1. That doesn't make any sense. So we're going to just leave the output is the input plus 4. And we know it's plus 4 because our starting point is plus 4. So to write our equation for this is going to be y being the output is the input, and again, the input's not being multiplied by anything other than 1, so we're not going to draw the 1, plus 4, since that's our starting point. Another good way to think of the starting point is where the y-axis is crossed. Since the y-axis is crossed at 4, that's what's going to be in the end of our equation and our starting point. All of those things are going to be the same. That's going to become very important in our next example. Let's go ahead and take a look at that now. Here we are at example F, and this time they've given us the graph, and we need to figure out the other parts, the table, the equation, and the word sentence. So good news when we have the graph is we can easily tell where our starting point is based on what we just talked about. Since we're going to be looking for when the line crosses the y-axis and it crosses the y-axis at 0, we know our starting point is going to be 0. Now we can figure out our rate of change. much easier on our graph. We're going to be counting our ups and our overs. So we're going to go up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. So we can determine our rate of change is 2 over 1, which simplifies to 2. Now we can use this information to make our equation and our word sentence. Making the table is much easier here because we can just take points that were already on the graph. So we can see that 0, 0 is on our graph. We can see that 1, 2 is on our graph. We can see that -2, -4 is on our graph. We can see that 3, 6 is on our graph, and 4, 8 is on our graph. Are these the only points that were on our graph? No, I just selected a few points from the line and wrote them in the table. You could have selected any points that were on that line and put them in the table. Now to make the equation, let's use the information that we have of the starting point and the rate of change. So we know our equation is always going to start with y equals, or the output, and then we need to figure out what's happening to our input. In this case, our rate of change is 2, so we're going to be multiplying each of them by 2, so 2x, for the x being the input, but then we're not going to need to add anything because our starting point is 0, so we're not going to write plus 0, so our equation is just going to be y equals 2x. Now we can write that in words as the output is the input multiplied by 2. Now you could have written that a lot of different ways. You could have said the output is the input doubled. That is also stating that it's being multiplied by 2. I just find it easier when we're making these word sentences to not complicate them so much and just use the words that we know, like multiplies. So the key in 4 representations to take one representation and turn it into the other 3 is to find the pattern. And the easiest way to do that is to find the starting point and the rate of change. It's not the only way to find the pattern. You could look at the table and say, okay, how do I get from 1 to 2 and 3 to 6 and 4 to 8? Well, I'm multiplying by 2. That is a way to find the pattern, but sometimes the patterns are more complicated than just multiplying by 2, and then it's helpful to have a starting point and a rate of change. This brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.